now we're going to look at Coulomb's law, the specific application and calculation of the electrostatic force on a charged particle, in this case the 20 nanocoulomb charge, due to two other charges, and that is the pink 25 nanocoulomb charge down here and the green negative 15 nanocoulomb charge down here. Now, to illustrate the point that I was talking about relative to not using the plus and minus for the Q's, let's do the Q2 one first. So, to calculate the electrostatic force, we're going to utilize Coulomb's law, K, Q1. Now, notice I didn't use negative 15, I used 15. 15 times 10 to the minus 9. So a nano is 10 to the minus 9. You don't need to memorize the prefixes, you will be given those, but nano is 10 to the minus 9. And then I multiply it by the 20 nanocoulomb, 20 times 10 to the minus 9 nanocoulomb Q sub 0 charge, divided by r squared, the distance between them. In this case, the distance between them is 2 meters, to get my 6.75 times 10 to the minus 9 newtons for the electrostatic force, the Coulomb's law of force between those two Q's. Now, I go and look at the plus and minus to see whether that force is attracting or repelling. And since they are opposite, opposites attract, so the force is straight down in the y direction, and that is where my green F equation down here comes from. There's no component in the x direction. It's downwards, so that's the negative. 6.75 times 10 to the, let's get the minus 7 in there. And that's where that green force comes from. Well, how about the pink force? Well, the Q1 has a value of 25 times 10 to the minus 9. My Q sub 0 still has 20 times 10 to the minus 9, and now we have to be a little bit careful, right, because the R is the R over here from the right triangle, right? So it's 2 squared plus 2 squared square root, so square root of 8, and then R squared is 8 to give a value, force value, 5.62 times 10 to the minus 7 newtons. So again, follow this procedure precisely and you will always get the correct answer. So no positives and negatives, we just get the value for the Q, the magnitude. Now we go back and look and see whether it's attracting or repelling. In this case, it's repelling, so we get the up and to the right force here. I have a little more work to do now. So when they're not right on the axes, we now have to do inverse tan to get the 45 degrees. That's the angle here. And since up and to the right, when I put it into component vectors, right, my F sub x is going to be the value of the force cosine 45. My F sub y is going to be the value of the force sine 45. So it's 45 degrees to get the same answer in this case. But that is where my pink F force comes from down here. To the right was positive x hat up in the y direction, and I used sine and cosine to get my answer in component form, and then that's it, we're done. We are simply adding and subtracting like components to get the net force. Now, one word of caution. Occasionally I have students who try to take a shortcut. They try to say, I'm not going to use sines and cosines at all. Who needs sines and cosines? And I'm not going to worry about Pythagorean theorem. Basically, you are not going to follow the procedure I am asking you to follow if you just use component distances, the 2's, to calculate the f sub x and f sub y. Do not do that. So I don't even want to put anything into the notes about that. Just a word of caution. Follow the procedure exactly as I have it outlined here. Do not try to take shortcuts, and you will always get the right answer. If you're not using sines and cosines, you're not doing something correct. So keep that in mind. All right. Well, once we have the net force in component form, then if and only if we are asked or told to put it into polar form, would we go back and take our component vectors and construct the F net in polar form, where we would use Pythagorean theorem. We have our right triangle, right? Pythagorean theorem to calculate the net force, and then, of course, inverse tangent to calculate the angle theta. So I'll leave it to you to plug into your calculator and calculate that angle, but the concept is clear, and it follows what we've done with our forces and component vectors. So if you have any questions at all, we can certainly talk about this in class, but procedure is so important for calculating these types of problems.